Hi, everybody, and welcome to Echo Live. My name is Anna, and of course, I'm coming to you from the Michigan Science Center's Echo Distance Learning Program. Today, our program is called The Physics of Play. And this is because, based on the feedback that you gave us in your evaluation surveys, which, again, thank you so much to everybody who gave us feedback, who filled out our survey, told us what they liked or didn't like about Echo, and especially for telling us what kind of episodes that you'd like us to consider doing next. One of the most popular responses that we got from our Echo Live feedback survey was that you truly enjoy learning some activities that you can try at home. And so I've compiled a whole list of try this at home science activities, all based on physics today. So we've done a couple episodes where we've talked about kitchen chemistry, about electronic things that you could build in your home, perhaps coding or robots. But today we're going to be talking all about physics. And again, you can try these experiments at home. Yesterday, we did a big do not try this at home experiment session all about combustion. Again, we never recommend that you play with fire at home. It is incredibly dangerous, and we should leave that to the professionals. But let's change it up and do some try this at home physics stuff today. If you haven't done so already, go ahead, introduce yourself in the chat of whichever program you are tuning in on. Let me go ahead and see. Oh, hello, Evan from Texas. Hello to all of our friends joining in on YouTube, like Kennedy as well. Hi, everybody, and welcome. I'm excited for today's program because I've got a few different activities for us to show you. The first one I'm going to start with is something that was actually invented by kids just like you way back in the early 1800s. Now, around that time, many families were moving west across the country as we were establishing new cities and new towns off of the East Coast, where most people originally settled, or originally those large cities were located. As these families traveled west, they also moved away from things like toy stores and shops where kids could actually purchase toys or things to play with to occupy their time. Now, this is a great story for all of you at home, that kids are just as inventive as adults, if not more, because you have the best imaginations out there. You can't argue with that. And so kids back then had to get kind of creative if they wanted to come up with their own toys in order to keep themselves busy and have things to have fun with when they were far away from stores. So this toy that they invented is called a button flywheel. Back then, they used to call them buzz saws, but don't worry, it's not a saw at all. This toy is safe and pretty fun to play with and really, really simple to construct. All they used to use was a jumbo button or something kind of similar, just like the buttons here on my lab coat, but think even bigger. Maybe you've seen those at a craft store, and then some sort of cordage or string. Now, back then, if they didn't have buttons, they were forced to get kind of creative, which is exactly what I decided to do today. So instead of pulling out some jumbo craft buttons, I actually don't have any of those laying around my house. Instead, I looked around and figured out what I could use as a substitute, or how I could create a button out of some common household materials that we all might just have laying around already. The first option I came up with was this right here, which looks kind of like a button, but it's actually just the bottom of a Pringles can. I just cut it off. So I just used a pair of scissors and I just cut the cardboard tube off of this aluminum piece. And then I took a screwdriver and I just poked 2 holes through it. Now, I also put a piece of duct tape over it because when I did that, this metal got just a little bit sharp. So if you choose to do the same thing at home, if you choose to use a Pringles can, remember that depending on how you poke your hole, there could be some sharp edges on the back. So I just covered them with the duct tape, kind of smushed them flat, and now they're not going to hurt me. But we said that the only other thing you really need besides your makeshift button, which could be something like this, or you could consider using something like, ooh, that looks fancy because it's green like my background. But this is just the lid off of a bottle, an empty bottle that I had. Or you could consider even something like something larger. This is the empty lid from my coffee canister. And again, you just need to poke some holes in it, just like a button that you might attach to your clothes, and then take your string and feed it through the holes. Got it through one side and through the other. But let's talk about what makes this a physics toy. One of the most important concepts that we discuss when we're talking about physics is potential and kinetic energy, which is really the way that this toy works. I'm just tying my strings together, which is going to allow me to wind this toy almost like a top. And so what we're going to do is I'm going to take my string, put my makeshift button or my Pringles lid right there in the very center of our toy. And I'm just going to put 3 fingers through each side of the string. This allows kind of a gap to form. And then I'm just going to very gently, let me zoom back out, start to loop my button over and over and over and over again. As you do this, you'll notice that the string starts to get tighter and tighter and tighter on your fingers. That is you storing up potential energy that's ready to be used or ready to be converted into kinetic energy, that energy of motion that we love to talk about here on Echo Live. So what I'm going to do is, now that I've coiled up my string, it's on there pretty tight, not hurting my fingers tight, but it's on there pretty nice and tight. I'm just going to gently start pulling open and closed my fingers, and let's watch what happens. Just like with any toy, it takes a little bit of practice to get it going, but I think I've actually got it pretty well figured out here. Let's wind it back up. Might be better if I don't stop it in between, but now that we understand, see that I'm just spinning it around and around, and then I'm just going to start pulling on the string, which is kind of releasing that tension. You'll get better and better at this as you go. You can even see that as I start to work, now the toy is starting to wind up on its own. And I'm not sure if you can hear this. Let me put it nice and close to my microphone. I want to know if you can hear this sound. Ooh, you can hear that? It sounded like a buzzsaw, which is exactly why the kids back then called it a buzzer or a buzzsaw, because it makes this incredibly fast whirring noise. Now, I don't just have the Pringles can. I have a couple other options. The easiest thing I could find to make one of these out of, if you want to make it out of something very simple, is just some cardboard. So I just had an empty box laying around my house, and so I took some cardboard, and for my first one, I just cut it into 2 of the same size squares and tape them together. Now, if you are going to try this at home, it's important to remember what contributes to potential energy, right? There are a few factors that come into play. We think about this diagram a lot, or something pretty similar, right? Where when a bicycle or even a roller coaster climbs to the top of a hill, at the very top, we say that it has the most potential energy, or energy waiting to be used. There can be plenty of factors that go into this. How high is the hill? So the higher the hill, the higher your potential energy, but also how heavy is the object. So the bigger the object, like the bicycle or the person riding it, that also contributes to potential energy. The larger your mass, the more energy you can put into that system and get back out. So kinetic energy goes in, turns into potential energy, and then kinetic energy comes out. So the reason I taped together 2 pieces of cardboard here, and not just one, is to give this toy more mass, to make it just a little bit heavier, which is going to allow our toy to spin much better. Now, if you're having trouble getting your string through the holes like I am, you can either try the trick where you put a piece of tape over the end, or I've also found it to be easy to just poke something like a pencil or a screwdriver to help guide your string through those holes that you've poked. I actually used the same screwdriver to poke the holes in my cardboard because it's not sharp. It wasn't going to hurt me when it came out the other end. Again, I always want to have you guys be very, very careful at home, but you can make these using really anything laying around your house. If you want to turn it into an experiment, right? We've talked about experiments lots of times here on Echo Live as well. If you want it to be an experiment, you can make several button flywheels and use different materials, or use the same materials but change the shape. So for this one, I cut a square out of my cardboard, but you could also cut hearts. You could cut circles like my Pringles lid. You could cut triangles, and then you can figure out which shape makes the best button flywheel. Let's zoom out just a little bit there. And let's wind this one up and show that even though we've changed our materials, that process of converting potential to kinetic energy works just the same. So as we wind it up, we are storing potential energy in the strings, which is then ready to be converted. And you might even be able to hear this one too. It makes a really loud noise, and I can actually feel gusts of air coming off this button flywheel. And really, as long as you continue pulling your hands in and out, the string will continue winding itself back and forth, converting to potential to kinetic, potential to kinetic, over and over and over again. Really, the limit is just how tired your arms are going to get over time. Now, I will tell you one last piece of safety information that I've learned from making these button flywheels for many, many years at the Michigan Science Center, is that if you have long hair, like I do, you'll notice that I pulled it off to the side because I've only experienced this once, but it was pretty terrible when it happened, is I had one friend hold their hair too close to their button flywheel, and it got caught up inside. And we did have to do a little bit of a haircut in order to release the button flywheel. So keep your hair back. If you've got short hair, then you're good to go. Just something I thought I would warn everyone about because I know it was unfortunate the first time it happened, and certainly something I had never really considered before. But that is our first physics toy, all about converting potential to kinetic energy, which is the exact same principle that we saw with my popsicle stick chain reaction in a previous episode of Echo Live when we talked about nuclear science or nuclear energy. I'm going to show you exactly how to set up a popsicle stick reaction of your own from the very start. And it all has to do with weaving these big jumbo craft sticks in order to store that potential energy. Let me zoom back in. Now, again, the limit to this one is not in the amount of energy. It's really in how many popsicle sticks you have for this one. So if you've got hundreds of popsicle sticks, you're in luck. You can make a pretty long chain reaction, but the principle will be the same behind this reaction no matter how many popsicle sticks you use. But basically, we're going to store up our energy by weaving the popsicle sticks. So we're going to cross them over each other. And then the trickiest part is getting this started. So you'll notice that as we move through this, you always are in this process of going under and over. And it's important that you don't let that potential energy that's being stored in your popsicle sticks release before you are ready. Ooh, someone in Zoom said they love this one, and so do I. It's a little bit tricky to get started, but truly it's not that difficult once you're past your first 3 popsicle sticks. So again, we're going back with this process of under the first popsicle stick, but over the one behind it. Let's add in another one here. We're going to go under the first popsicle stick, but over the one behind it. And now you'll see I'm starting to turn it into this kind of pattern here. So on our next popsicle stick, when we add it in, we'll be going under and over. Set it back down. We'll be going under and over. And you just repeat this process over and over and over again. Since these popsicle sticks are under a lot of tension, you can even feel it as you move your finger around. You can feel that the energy wants to be released from this reaction, but we're not letting it. We're continuing to store up potential energy by weaving popsicle sticks under and then over our popsicle sticks here. Let's add 3 more and then we will release. But we said that this is certainly not the limit. You could do this with hundreds or even thousands. I think the record is over 400,000 popsicle sticks weaved into a chain reaction like this one, which is pretty impressive, but it takes many, many hours to set up. And if you make one mistake, if you have one popsicle stick go off too early, then you're out of luck. You've got to start all over because these popsicle sticks want to be free. They want to be released, but we are not letting them. All right, so we've added in our last popsicle stick here. Kind of shift it to the center of our camera. You can zoom out just a little bit because I think this one's fun when you can see kind of the entire reaction. We are going to convert our potential, our stored energy through the bends in these sticks to kinetic energy in 3, 2, 1. And they're really, like we said, this one can be a lot of fun. You can set it up across the entire floor of your house. Certainly do it somewhere where you've got some space and no one's going to disturb you as you're working on your project, because like we said, you want it to go off all at once, not just a little bit at a time. All right, I've got another fun experiment, and this one has to do with using the potential and kinetic energy stored in a rubber band. Now, I'm sure we've all used a rubber band before to maybe just pull back to create our potential energy and then release, maybe to shoot at one of our brothers or sisters, maybe to get our parents or our pets, but that's pretty easy. And I thought I might teach you guys a cooler way to build something, again, using these jumbo craft sticks in a different way. We've done this once before. A lot of people told me in their evaluation survey that they loved learning about the popsicle stick catapult. And I love the popsicle stick catapult too. So while I was browsing the internet, looking for some fun other activities, I found a really awesome popsicle stick crossbow. So I'll give you a closer look at this one. In our popsicle stick crossbow, we are attaching our rubber band here down some popsicle sticks, and we'll show you how to kind of arrange these if you would like to create yours at home. And then really similar to our last popsicle stick creation, you can see that I have kind of a lever, which is going to help store our potential energy as we pull back on the rubber band. To release it, it's really simple. You just, again, you see this little lever here, just push it, and it throws your rubber band. The cool thing about this popsicle stick crossbow is that we can actually add objects to it as ammunition. Now, if you promise that you're only going to ever use this popsicle stick crossbow for target practice at objects perhaps outside, things that are certainly never going to be shot at your brothers, your sisters, your parents, your pets, any other living thing, you can add things like these bamboo skewers. They don't come out very fast, but they do work pretty well. And so you would just pull back on your bamboo skewer. You would attach it where your rubber band goes underneath your lever and aim where you want to go. 3, 2, 1. Oh no. One more retry here. The trick is, I'm going to show you up close as I load our crossbow here. The trick is to get the rubber band. A thicker rubber band works better than the one that I have on here, but we can do that on our next try. Is to actually get the rubber band to pull on the end of your skewer. And so you want to kind of pull back on it, push it underneath your lever. Oh, there it goes. Pull back, push under the lever. We are now storing our potential energy, and we can aim it in 3, 2, 1. There we go. That one shot pretty good across the room there. And really the only materials you need for this are the same materials that we used for our popsicle stick catapults, but instead of, we'll just need another piece of drinking straw. So it's actually good because we had you use one little piece of a plastic drinking straw for our catapult, but this time you can use the other piece as kind of your guided part. So what I've done before the program is I've taken a couple popsicle sticks and I've made some modifications. Into these, I've actually just drilled a tiny hole in the top. Now, I used a power drill to do this, but you certainly don't have to. You could, again, use a screwdriver, you could use a pin, but this is just going to be how we attach our rubber band to this. You could also consider just coiling your rubber band around really, really tightly, but I found that drilling the hole is really the easiest way to get this contraption to work. So I have some other popsicle sticks here, our drinking straw, and we're just going to assemble this all at once. So we're needing to create that kind of crossbow shape by, all I did before the program is I cut this one on an angle, but I'm going to show you how I did that because it's really, really easy and simple. Oops, let me get my camera to focus here. Doesn't want to. So all you're going to do is line them up because you want them to be symmetrical, and you're just going to take a pencil. Oh, probably should do it on the correct side. That would be super helpful. But we're going to do it over here. And then we're just going to cut on that line using a pair of scissors. So scissors work great for this. You don't need to use a knife or anything else. You just need to make sure you're being careful as you cut just the little end knob off of your popsicle stick there. And then they just go end to end over the other popsicle stick, which brings them into this shape. Hot glue is your best option for getting everything to hold together for this experiment. If you don't have hot glue at home, you can use regular glue, but of course, like we always tell you that if you're going to use regular glue, it works just as well. You just don't get instant results. You're going to have to just wait until everything dries, because we are going to be putting some tension on this system when we pull back on that rubber band. And so everything needs to hold on very, very tightly. So I've just glued those ones across there. Because it's hot glue, they're already ready to go. We're already ready to add in our next popsicle stick. We'll take another one here, doesn't matter what color, and we're just going to attach it right here in the center. Just add a couple drops of hot glue. 1, 2. Glue our shaft on there. Now, the reason we're just adding more length, right, is the further back you can pull your rubber band, like on this one, the further back you can pull it, the more potential energy you create. So you could stop here, but you can also keep adding length to this crossbow. You can see that I've added, on my original one, I have just a little bit longer of a shaft on it. And so we'll go ahead and I'll show you how to do that. The easiest way is if you flip it over, and you can just glue another one right here to the back where you have this kind of overhang. Again, just a couple dots of hot glue or regular glue. Flip it over, and we are just about finished. So I just have one more here. I'm just going to attach, make sure everything is nice and even. And trying to keep everything as straight as possible is really helpful too. So keeping everything straight and lined up is good because, right, we are using this for aiming. And so we want whatever we slide down into our straw to end up leaving the straw straight. You're going to take your piece of drinking straw. I don't want this little spoon-shaped end. And I'm just going to cut off one small piece for my lever and use the rest as the way to guide my ammunition. And so it can be this long, it can be shorter. I think I want mine to be just a little bit shorter. And I'm just going to then go ahead and hot glue it down into place. Just putting a couple dots of hot glue, taking my drinking straw, again, trying to keep it as straight as possible. And you can see it's just right there on top. Letting that dry for just a second. And then the last thing we're going to do is, or not the last thing, but the next thing we're going to do is attach our potential and kinetic energy storing device to attach to the holes that we've poked into our popsicle stick. So again, you could try wrapping this around really tightly instead, but what I've found to work the best is really just using the hole in the popsicle sticks. If anyone has any questions while we get our last finishing touches here on our popsicle stick crossbow, definitely, like always, type them in the chat. Let me know what you're thinking. I'd love to answer any questions that you might have about, if you have questions about how I'm doing this or the way the crossbow works, I can definitely answer those for you. Evan definitely told us, caution, do not use on living things. You are absolutely right. We don't want to ever use this on anything that's living. These are just for fun, just for toys. I'll show you an alternative to something you could load into it, something that's not sharp. You could use smaller drinking straws, so kind of like those coffee drinking straws that are smaller. So you would just need something that could fit through this. But another really fun and very safe option is shooting something like a Q-tip. So again, you'll just need to make sure that your straw is large enough that your Q-tip can easily fit inside. But you can shoot Q-tips with these. These probably safe to shoot at living things as long as you have permission, as long as that person has consented to being a part of your popsicle stick crossbow. Of course, you'll have to make someone their own. That way it's a fair fight. That way everyone has one. And the very last thing we're going to add to our crossbow here is the lever. So we just need a short piece of popsicle stick. On my last one, I kind of just angled it, kind of turned it into this interesting little shape here. That's not necessary. I just kind of liked the way it looked. So that's the reason I chose that kind of design. And that is our lever. So you'll need your piece of chopped off drinking straw. You're going to be angling it and then attaching it just like we did with our popsicle stick catapults with a rubber band. So you can just wrap it. I've actually found better luck wrapping it around a couple times on its own. Then sliding in the straw to act as the lever, and then just securing it into place. So just like with our catapults, right, we want to make sure that the direction is holding the backside up. So make sure when you test yours, right, that this kind of rounded edge towards the back of your crossbow is pointed up. And so then when you push down on it, it releases that point for your rubber band. You can give it a test, make sure that your rubber band will stay under your lever and release. Pull it under your lever and release. Seems to work really well. So let's give that one a shot with our Q-tip here. So you'll just load your Q-tip in just like we did last time. Make sure that we're getting our Q-tip in front of our rubber band. So it was under our lever, but not in front of our rubber band. Oh, pulled the rubber band really tight on this one. So it's going to shoot really far, but it is definitely making it harder to manipulate, especially when I'm trying to keep it held towards the camera here. All right, let me try this. I'm going to try pulling back on our rubber band first. There we go. Definitely messed up our fluff there. But we'll go ahead and let's give it a shot. Oh, stuck in my straw. Yep, the fluff is an issue. Let's redo. Load up our ammunition, pull back our rubber band, and 3, 2, 1. Oh no. Well, I'm going to show you on my other one because I was confident that this one worked with the Q-tips. I did quite a few tests, worked out pretty well. Pull back, load up our Q-tip, and 3, 2, 1. Gonna let me down, science. The science is solid, the science is here. I think it is just my nervous energy here. Get it loaded up, locked into place. Here we go. Last try. 3, 2, 1. Stuck in the straw. Well, you might need to do some finagling, which is one of my favorite words, or re-engineering on your own. Raul talks to us all the time about how engineering and invention is a process, right? So if you try out your catapult and you notice that it has some problems or issues, you have all the knowledge you need in order to fix it, in order to make it better, right? I've given you the general concept about how we're using our potential to kinetic energy. Our potential energy while the rubber band is pulled tight is stored, and then kinetic is when it's converted all at once. So you'll notice that they don't look identical. They look similar, but not identical, and that's okay if yours don't either. You can make changes to these at home. These are all really simple materials, things that you can easily get at the craft store or the grocery store so that you can try some of these experiments yourself. Now I have one last physics game or physics trick to show you. And this one doesn't even have to be done at your house. Maybe you are out in public, say, maybe you are with your family out at a restaurant and someone challenges you on your science knowledge. They tell you, show me a science trick. Well, I've got one for you. And all it takes is some silverware, a glass, and a toothpick. Now, this one is all about balance or center of mass. We talked about how mass can contribute to potential energy, right? The greater the mass, the more stored energy you have, and the more of it can be converted into potential energy. But mass is not always evenly distributed across an object. So in this example, we're going to test out where exactly is the center of mass when I take 2 pieces of silverware and I just link them together. So you can see that I just put the tines of the fork, 2 of them on the inside of the spoon, 2 of them on the outside of the spoon, just kind of slid to hold them in place. You'll notice that now they are attached to each other. And the first thing you'll want to do is notice the center of gravity, that the center of gravity is not in the mid, or it's more towards the middle. It's not where they're attached. Because the fork is slightly heavier, you'll notice that I have to move my finger slightly off to the side or with the fork in order to compensate. Every spoon and fork would be different. They might be different in size, they might be different weights or different mass. And so you'll really have to do a test by balancing these on your finger. Now, the next thing we're going to introduce is a toothpick. And now we want to find the center of mass if we were to combine our silverware, our fork and spoon here, with the cup. And that makes it a little trickier, right? It wasn't so difficult to find the center of mass between the fork and the spoon because they are not identical, but pretty similar. And we have a pretty symmetrical system going here. But what we're going to do is we're going to take our toothpick and we're just going to push it between the tines of the fork, right where you found that center of gravity in your initial demonstration. You can again try to find it. You might have to kind of wiggle it back and forth. Really try to find that center of mass so that it doesn't tilt off in one direction. And then we're just going to try to balance this toothpick on the drinking glass. I want to get it so you can all see. And you'll notice that the center of mass, the balancing point, is pretty interesting. We can adjust our toothpick here. And we've found it. Now, I'm going to turn the glass, but of course that's going to kind of jostle my system here. So let me reset. I want you to see it a little bit better. But we can almost get our fork and spoon to balance on this glass, which is pretty cool. You'll notice that your center of mass also changes depending on which slot you put your toothpick through. So keep that in mind as you are kind of working through this challenge on your own. You can balance it here on the end. And then I have one more fun thing to show you once we find that center of mass one last time. Don't get discouraged. I'm not getting discouraged. You've watched me here on Echo Live mess lots of things up if you've been with us over the last few months. You can never give up. You never quit. You just keep engineering and keep solving through the problem in front of you. All right. We've found our center of mass, but our spoon and fork are moving, which I'm trying to kind of stop so that it doesn't fall. Now, this is the part that I recommend you maybe don't try if you're out at a restaurant, but you can certainly try if you were to try this at home with your parents' supervision. Now, what do you think might happen if I take our lighter here and I start to burn the ends of the toothpick? Does anyone have a hypothesis or a guess? Do you think it might change the center of mass that's on our system here? So right now they are perfectly balanced. They are not the spoon and fork are not touching the glass whatsoever, even though it might look like it on camera. They are perfectly balanced over that toothpick. But what do you think is going to happen? Justin thinks it might explode. You've been watching too much Echo Live. It could explode, I suppose. We've made lots of things explode here on Echo Live, but not everything. So we'll go ahead and we'll light our toothpick here. Start to burn it from that end first. And let's watch what happens as the flame travels closer and closer and closer to the edge of our glass, right? We're almost running out of toothpick here. Let's see what happens. Wow. And would you look at that? Our flame went out. As soon as it got to the edge of the glass, the flame completely extinguished itself. So it did not continue burning through. Let's try it on the other end. This one's a little trickier. Again, you want to make sure that you don't bump the table as you try this experiment, because everything is perfectly balanced. And what we were hoping might happen, right, is that as we remove pieces of the toothpick, but you'll notice as soon as that one gets to the tines of the fork, it stops as well. We didn't need either end of the toothpick. They did not contribute to the center of mass for our system. Everything remains completely balanced. And on a nano level, there's not enough oxygen getting underneath the toothpick where it's connected at those points of mass in order for the toothpick to continue burning. And so it will always go out. It will always leave your fork and your spoon perfectly balanced on these little nubs. And you can almost even just get rid of them. You can see that now I've kind of eliminated the ends of our minor adjustments. Now that I've even knocked them off, right, you can't even see them. So this is, again, something that you can try at home. You can try your balancing trick when you are out and about, maybe looking for a little bit of physics that you can do to keep yourself busy. It's super fun, super impressive to people who maybe want to see what you've learned so far on Echo Live. And when you're done, you just pull them apart, no harm, no foul, and you can put them in the dishwasher and wash them for being used for food. All right, so if anyone has any questions about any of our experiments, definitely let us know in the chat. Otherwise, of course, we'll end the show by going over just a couple announcements. Thank you to everyone who's been tuning in to Echo Live since we got started back in March. Today is our last day of daily live Echo programming, but we are not done doing Echo Live. We will still be doing Echo Live every Tuesday and Thursday at 2:30 p.m. Eastern. You can continue tuning in on our Facebook, our YouTube, and right here in Zoom every Tuesday and Thursday at 2:30. If you are looking for more things to do outside of that, you can sign up for our virtual summer camps, which start on Monday. Courtney Poloni, if you are out there watching, you won our free week of My Size Spark Camp for filling out our Echo Live evaluation survey. We sent you an email. All you need to do is reply to us and let us know which week of camp you are interested in signing up for. If you did not win this free week of camp, everyone else, you are still welcome to sign up. I hope that I'll see you all there. Otherwise, I will see you all on Thursday for another really cool program in our virtual planetarium with Paulette. Let's see, do we have any questions before we go? Thank you everyone so much for tuning in. It's been really great getting to see everybody in the chat every single weekday. I hope I'll continue seeing you here throughout summer and have a